Hello and welcome to this video. My name is Nakić-Alfirević. I am a software developer, and in this video I'm going to be showing you a product that myself and my team have made called QueryStorm. So QueryStorm is an add-on for Excel that lets you use SQL, C# and VB.NET inside Excel. It has an IDE component, a runtime component, and an app store. Let me show you what it can do. So there are three basic things you can do with QueryStorm. The first one is processing data. Second one is automating workbooks, and the third one is building and sharing custom functions. So let's start with processing data. Over here, I have some sample data that I downloaded from Kaggle. It's a list of movies, and for each movie we have a title, a list of genres that the movie belongs to, a director, ratings, and whatnot. So in order to process this data, the first thing we need to do is convert it into a table. So I'm going to press Ctrl-T. And once it's a table, we can go over to QueryStorm, start a new C# script, and start querying this data. Right off the bat, the first thing we can do with the C# support is we can run LINQ queries against anything that's marked as a table inside Excel. So let's see if we can find all of the movies with a rating that's less than, let's say, 2. Table 1, where m for movie, m.rating is less than, let's say, 2. Okay, press F5. Okay, we just have one. We can double click it and it takes us to the movie. In the results grid, we have all of the columns that are present in the original table. And we also have an additional metadata column called __ address, which tells us where the row is in Excel. We can change this to, let's say, 3, so we get more movies. And, well, actually, there's not that many terrible movies. Let's do less than 4. Okay, there's a few more there. This is just a basic query. We could do something like this very easily with Excel's native functionality alone. But with C# we can do more advanced things. So one thing that would be quite difficult to do with just native functionality alone would be to analyze this data set based on genres. The reason for that being that all of the genres for a particular movie are bunched into the same column. So basically what we would do is we would break up all of these rows into multiple rows, one for each genre that the movie belongs to, and then we can aggregate on top of that. Before we do that, we should change the name of the table to, let's say, movies. So as soon as we do that, our old variable disappears and we get the movies variable where we can write our queries. So basically what we want to do is for each row, we want to break it up into many rows. So instead of, so for each movie, we want to take the genre column and split it up based on the comma. So if we run this, we're just going to get a bunch of rows. For example, for Guardians of the Galaxy, we're going to get action, adventure, sci-fi, which are these three. We can project here also the genre and the movie title, just so that we are clear on what we're doing. So let's select. We're projecting the genre, taking the genre and projecting the genre and the movie title itself. So if we run this right now, we can see that we have indeed split Guardians of the Galaxy into three rows, and then Prometheus into 3 rows as well, because it belongs to 3 genres and so on. And we can now take this result and start aggregating on top of it. So we can do group by, take this object and group it by genres, and we can project out for each genre the genre name, which is the key, and we can also project the number of titles for each genre. So that's going to be g.count. And we can also project the average ratings for the movie. So that's going to be average rating equals g.average. And then we can do x dot, and instead of using title here, we're just going to return the movie row itself, and we'll just pass in the rating, the movie dot rating over here. So if I press F5 now, we can see that the exact numbers for each genre. So for each genre, we have the number of movies that belong to it and the average rating. We can now write this result by pressing Alt-Insert, and we can then close the IDE and apply some, I don't know, formatting or whatnot, just so we get a better visual sense of the data. This is useful for one-off processing of data. But what if we wanted to make this automatic, so we can process the data without even using the IDE? That brings us to our second topic, which is setting up automation using C#. So let's get back to the IDE. And for a start, if we save this script and go into code, we'll notice that the script is saved in the script folder in the project node over here. For the purposes of automation, we're not going to be using a script, so I'm just going to copy this code, close the script, and I'm also going to take this project and delete it. The files in this project have been scaffolded by QueryStorm. That's been done automatically, so I'm just going to delete this project just so that we're starting off from a clean slate. And I'm going to right-click on this workbook node and create a new project. Now, QueryStorm has scaffolded two items for us: the app.cs class, which is the entry point to the application, and the project config file, which basically lets us configure the project. So we can supply metadata that describes the project itself. We can also provide references to .NET DLLs that are being used and to NuGet packages that we're using over here. So let's close this. So to set up automation, we need components. A component is basically a class that controls any part of the workbook. It can control the entire workbook, or it can control any arbitrarily defined section of the workbook. So you can have many components, each controlling their own part of the workbook, or you can have one component controlling the entire workbook. So let's define a component. We'll just leave it as component 1. So as you can see, a component is basically just a class that derives from component base. The QueryStorm scaffolding has generated over here a bunch of code for us. I'm just going to get rid of all of this code from here, and I'm just going to leave this event handler over here. Let's get rid of the usings as well. And in the message box, I'm just going to show hello world. So this event handler is intended to react to events from the workbook. In order to invoke it, we need to send an event that's called sheet1 command button 1. This is an event that we can send from an ActiveX named command button 1 located in sheet 1. So the default command button, if we go to properties, is named command button 1. And since it's placed in sheet 1, that's going to fire the exact event we need. If we wanted to rename this button, we would just change this event handler over here. So let's see if it works. First thing we need to do is build this project. And once we do, we can go to the developer tab, exit the design mode, and click the button. Sure enough, we get hello world. And just to show that this is exactly what's being invoked, I'm going to change this to hello world 2, build the project, and click the button, and it's showing us hello world 2. Okay, so let's get rid of this message box, and let's now paste in the code that we've had from our C# script. The code is more or less fine as it is, but we don't have access to the movies table. C# scripts in QueryStorm have access to all of the tables and all of the variables implicitly. But in components, we need to be more explicit about what data is coming in and what data is going out. So to get access to the movies table, we need a property and we need to data bind it to the table in Excel. Here's how to do that. So let's define a new property. We're binding to the movies table. We already have a type prepared for it. And the name of the property is going to be movies. In order to bind this property to the table from Excel, I'm going to use the bind table attribute and specify that this is referring to the table movies with the lowercase m. And we'll just use the property over here. And just to make sure that this is in fact working, I'm just going to log the results over here. So I'm going to store the results in a variable. And I'm going to log the count of the rows that we get. So let's build the project again, click the button, and sure enough, we get 20. We should have 20 genres over here. So this is row 4 and down to row 23, which is 20 rows. So let's see if we can take this the data and write it into this table. So first off, let's get rid of the data that we've had from before. And let's see if we can write these results into this table. In order to access this table, we are going to need another property. So we can define another property. The name of this type, it basically depends on the name of this table. So we haven't given this table a name. It's just table 2. Let's rename it to results. Once I rename it to results, we should have here a results table type. Now, you might be wondering where this type came from. It's basically auto-generated by QueryStorm. So if we take a look at the lib folder over here, as soon as let's say if I add a new table over here, the current type is context types A2, A3, blah, 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 DLL. If I create a new table, it generates a new DLL that has a different ID over here, and it contains the new types. If I change the name of the column to something, it's going to create a new DLL and give us the new types in the new DLL. So let's get rid of this table and continue about our way. So in order to access this data, we said, okay, we're accessing the results table. We need to bind to it. So bind table. The table name is results. So we should have access to the results table. And basically what we want to do is we want to take these results and just write them into this table. So let's access the results table. The first thing to do would be to clear any previous results, because we might have had some previous results over here. And the next thing is to just go through each item in the results and just copy them into the results table. So we can do that by this way. Okay, new row equals results, the results table. We call the add row method, and then we'll just copy the properties one by one. So new row dot genre equals r dot genre, new row new okay, need this, new row dot count equals r dot count, and new row dot average rating equals r dot average rating. So the last thing to do is call results.savechanges. We have to call result.savechanges because these changes are all in memory until we call save changes. Writing to Excel takes a long time, so it's best to batch all of the data processing, do it in memory, and then as a last step, just call save changes. So once we're happy with that, we can build the project. Click command button 1, and sure enough, it populates the data. Let's say we also wanted to have to define some parameters that we're loading from the worksheet. So let's say we only want to display genres that have a minimum number of movies inside them. So let's add a cell here called min count. So that's just a label. We're going to use this cell over here. So cell styles, input. Let's put 100 over here, and we should add a name to this cell. So that's going to be min count cell. In order to use this in our components, we need to define a property which is integer, and we can call it min count. We're binding this property to the min count cell. And once we do that, we can use the property in the component where m.count, it's basically not, it's not m, it's g for genre, is greater than min count, greater than or equal to min count. So press Ctrl+Shift+P to build, click the button, close the IDE just so that we're we're not hiding any rows behind it. So if we change this to 50 and click the button, we're getting a few more. If we put 1 and click the button, we get all of them. If we put 300, we should get only a few. So action and drama. Okay. And if we wanted to make this automatic so that as soon as we change this, the table updates, we could do that as well. Changing of the cell also includes firing of an event. So we'll just use the event that gets fired is the event is the name of the cell. So we can put that over here. Build. And now, as soon as we change the number over here, the table below updates. So there we go. So basically what we're doing here is combining the workbook as a document with business logic written in C#. And this business logic can be as complex as we need it to be. And we can even use NuGet packages if we want to. So to access NuGet packages, we can right-click the project node, click on Manage Packages, go to NuGet Packages, and just download any NuGet package that we need to use in our workbook application. So once you build this automation into the Excel workbook, it becomes part of the workbook and it's distributed inside the workbook. The only thing that users need to have is they need to have the QueryStorm runtime installed, which is a 4 megabyte installer. It doesn't have any additional licensing, so you don't have to worry about running into another paywall. And the last thing I wanted to show you is building and sharing custom Excel functions. Basically, what it allows you to do is you can write functions in C#, you can publish them to a network share or the cloud, and then have your colleagues and users to install your functions inside Excel. It makes it very easy for developers to help the non-technical users around them. So let's see how that works. Let's close this workbook. We're not going to save it. Just going to make a new one. Let's open up the IDE. So again, we can create a new project in the workbook, or we can define a project at the machine level. Both projects can contain functions. For the purposes of this video, I'm going to create a new extension project over here. I'm just going to call it ABC Functions. Okay, just to keep it at the top. I'm going to delete this one. This is an example one. And I'm going to open up the project. As before, we can see that we have a app class over here, which is the entry point of the application. We have a scaffolded class over here, which we can use to start writing business logic. I'm not going to use this one, so I'm just going to get rid of it. And we also have a project config file over here with the metadata and project settings. I'm going to close that one because I don't need to do anything with that at the moment. And to define functions, we are going to need a Excel functions class. And the default scaffolding gives us a class which already defines a function decorated with an Excel function attribute. So as soon as we build this, we are going to get the add method inside Excel. So if I call this right now, I have a new add function. I can pass in the numbers and it adds. Just to demonstrate that this is what's being executed, I'm just going to change it, build it, and as we can see, we now get a plus b plus 100 as the result. We can do more interesting stuff here. So let's say we wanted to, instead of adding two numbers, we want to take in a number and return the textual representation of that number. So there's a NuGet library for that. It's called Humanizer. So let's get that from NuGet. So Humanizer. Okay, Humanizer core, that one is going to do nicely for us. Once we have the function, the package, we're going to get extension methods for the integer type. So we are going to get the toWords method, which to get the method, we need to add the using statement, which we can do using the code fixer. And we're also not returning an integer, we're returning a string. So once we change all of that, we can also change the name of the method. So let's do convert to words. Once we build this, so as soon as we built this, this method disappeared. But we also have a new method here that's called convert to words, which accepts a single integer and returns the textual representation of these words. And we can do all sorts of functions here. So let's say we want to define a function that takes in some text and gives us a list of words that are included in the text. So we can do that by creating a new function called that's going to return an IEnumerable string, get words, accept some text, and it's going to return, and it's going to use regular expressions to break it up into words. So we can do regex dot matches, pass in the text, pass in the regular expression that we need, and use a bit of LINQ to extract the values. So we need to return the match.value. Okay, and we should definitely not forget to decorate the function with the Excel function attribute. So once we build this, we can do get words. We can use this as some source data, and we can see that we have a list of strings. This also supports using async functions. So let's say if we define an async function, get text after delay. So this function is just going to wait for a second and then give us a hard-coded string. So we're going to return a task of string, and we're going to await task.delay for 1000 milliseconds and return a string. We also need to decorate the function with the correct attribute. Press Ctrl-Shift-P to build. And you'll see that now when we invoke it, get text after delay, it's going to wait for a second before giving us a string. So I'm going to press enter, and then it gives us the result here. While it's waiting, the Excel remains fully interactive. So it does not block Excel while it's working. And the last kind of function we can define is a function that returns a stream of values. This is something that you might want to use for, let's say, stock prices, which change over time. Functions that return a stream of values basically return an object that implements an interface called iValueStream. So let's see how that works. So public static iValueStream. And functions don't need to be static, and in fact some of them are not if they're using dependency injection to get dependencies from the app class. They should not be static. But in the simple cases they can just be static if they don't have any central dependencies. So let's define our function that returns a value stream. That's going to be get stream of values, decorated with the Excel function attribute, and we're just going to return a new, let's call the class myStream. We don't have this class yet, so let's define it. So we can do make a class called myStream. This class doesn't implement the iValueStream interface. The easiest way to implement the iValueStream interface is just to derive from ValueStream base. We can use the code fixer to scaffold the necessary functions. Inside the start method, we're going to start providing values. So we're going to use task delay here as well. So we're going to make this function async. So what we're going to do is we're going to cycle for int I equals 1, I less than 10, I plus plus. We're going to, in each cycle, we're going to await for a task delay of 1000 milliseconds, and we're going to provide I as the result, or actually a string that contains it. So we can do something like this, and we should use string interpolation. So I think that should be it. We should get rid of the exception in the stop method. We're not using stop method at the moment. Stop would get invoked when you delete the cell from Excel. We don't really care about that, so we're good to go without it. So if we click build project right now, we can go over here and invoke the get stream of values function. And this is what it's providing us with a stream of values. And we can interact with Excel while it's doing its thing. We're not blocked in any way. So yeah. The really interesting part here is once we're done building our functions, we can publish our functions to a network share or to the cloud, and then other people can download them and use them. Here's how to do that. Once the project is built, we can click publish. In the feeds, we can select where we want to push. We can we should specify the author, the description, and some metadata about the package, and then we can publish it. Now, this list of feeds, you can add it in the extensions dialog. You go to manage sources, add a source, click on the edit button, and over here you can give the source a name. You can provide a URL, which can be a network share, a local folder, or it can be a NuGet repository in the cloud. So I'm going to delete this source, and I'm just going to use the my packages source over here, which is just a folder on my machine. So let's publish it. I'm going to put my name here in the authors, and in the description I'm going to put some demo functions. After that, I can click publish package. The package is published immediately since it's a local folder in my machine. If we take a look at the contents of this folder, it contains the package we just published. Now, anybody who has this folder added as a source can download the package. In this case, this is just a local folder, so nobody would have access. But if we publish to the cloud, everybody who had the URL would be able to download the package. So let's close this, and I'm going to show you what this looks like on a target machine. So to simulate a target machine, I'm just going to get rid of the QueryStorm IDE and just leave the QueryStorm runtime. To get rid of the QueryStorm IDE, I'm going to go to add-ins, com add-ins, click go, and then uncheck QueryStorm over here. Once I press OK, the QueryStorm IDE is unloaded, and all that remains is the QueryStorm runtime. The QueryStorm runtime can be installed separately. It's a 4 megabyte installation. It's completely free. It doesn't have any licensing associated. And as soon as you download it and install it, you already have access to a set of packages that my team and I have already built. So let's go to extensions. And actually, let's get rid of this ABC functions over here. So as soon as we get rid of it, the function results disappear from here. If we go to QueryStorm extensions, type in ABC, we can find the ABC functions package over here. If we hover over the title, we can see all of the functions that it contains. And we can click the install button. And as soon as we've installed, the functions are up and running again. There are some other useful functions in the extensions catalog. So if we go to manage sources, there are 2 NuGet feeds already predefined. One is NuGet.org, which is used for downloading NuGet packages. And the second one is the QueryStorm extensions feed, which doesn't have NuGet packages, but it has extensions. Technically, extensions are structured the same as NuGet packages, so just a convention, basically. There's no technical difference between the two. And so if you go to QueryStorm extensions, you can download several useful extensions that we've already built. I'm just going to demo a few of them for you. I have some of them already installed. So so for example, the Google Translate one, the Windy Query one, the Searchlight one, and the text one. So to demonstrate the query function, I'm just going to close this file, open up the another workbook where I have a demo for it. And here we have two tables. And in this cell, we have the query function. So the query function basically lets you use SQL on workbook tables. So if I start typing windy.query over here, I can do a select from the people table. And as soon as I do that, it gives me all of the rows in this table. I can also include the headers, and I can also tell it to automatically refresh when the input data changes. So that if I change John 123 over here to just John, this immediately updates. So over here I have an example with the join, just to show that this is actual SQL that's being executed. Let's get rid of this one, and also if we change this to, let's say, from sales, we can change this to marketing, and the results update automatically. The query itself is executed by a SQLite engine that's part of the extension. So any SQL that's a valid SQL query is going to run just fine over here. One thing I want to mention is we're not limited to just defining functions inside extension packages. We can also define general purpose extensions to Excel. So one of those is an extension called Searchlight that I have installed over here. That's this one. It doesn't, if we hover over it, we'll see that it doesn't have any functions, but it gives us additional functionality inside Excel. So let's say that this is, suppose this is a large Excel file and we want to navigate it. So let's add some sheets over here. So Searchlight basically helps in the following way. It gives you a shortcut which you can invoke, which is Control-Alt-F. And we can start typing over here. So if we want to go to sheet 1, we can just start typing and press enter, and that's it. If we want to go to sheet 3, we can do that. If we want to find a table called people, we can start typing that and navigate to here as well. And then we also have an extension for Google Translate, so we can do we can call Google Translate and say, hey, is this some text? And we can translate this to Spanish, press OK, and it reaches out to the Google Translate API and gives us back the results. This one requires a bit of configuration, so if I go into configure extensions over here, I need to edit my, enter my Google API key over here. So the point of this is you can build functions that you can use inside Excel yourself, but you can also build functions that anybody in your company or outside of your company can also use, as long as they have access to your to the repository where you keep the extension packages. The QueryStorm runtime is entirely free, so if you make something with QueryStorm, you don't have to worry about anybody having to pay an additional license in order to use it. If you want to publish your packages to an Azure Artifact server, you can go to the QueryStorm website, go to the documentation page, custom Excel functions, publishing functions, and here you're going to find, if you scroll down below, publishing to Azure Artifacts. I've made a short video where the entire process is laid out, from creating an Azure Artifacts account, setting up API keys and everything. It's a process that takes just a couple of minutes, so it's fairly easy to set up. So anyway, I hope you enjoyed this video. If you're interested in QueryStorm, go check it out at QueryStorm.com and tell me what you think in the comment section of this video. Thanks a lot and see you next time.